A football is punted straight up at 20 meters per second. What is the hang time, and how high is it at the peak of its flight? For this one, I want to remind you of two really important ideas from the peak trick video. The first one is that the vertical velocity of any object when it's at its peak is zero. That just means that it's neither going up nor down. It's that magical moment in time where it's just frozen for a moment. So you have a velocity of zero when it's up there. Second is if it lands at the same place that you threw it, then the time going up equals the time going down. And in this case, when you punted the football, it came back down to the same location where you kicked it from. So both of these are true, and we can really use them to our advantage here. A third thing you'll want to note is that the football ends up flying through the air, which means this is always going to be true. The acceleration on the object is 10 meters per second in the downward direction. Now we can use this in the problem because if the acceleration is minus 10, if the thing gets 10 slower every second, and it started with a speed of 20 meters per second going up, remember, when objects are going up, they get slower and slower and slower, right? So the amount of time that it takes before all 20 of this speed is sucked out of the ball ends up being 2 seconds. The amount of time to get to the peak time, is exactly 2 seconds. Now, if the ball spent exactly 2 seconds going up before it ran out of velocity, and the trip up and the trip down end up taking the same amount of time, then the total hang time is 4 seconds. I won't even bother writing out lots of equations for this one. Should be able to do it in your head. The second part is a little tricky. It wants to know how high is the peak going to be. Now, during the upward part of the ball's flight, its average velocity was 10 meters per second. And I know that because it started with a velocity of 20, but at the peak, its velocity was 0. So if you started at 20 and ended at 0, if you find the middle of those two numbers, you get an average velocity of 10 meters per second. Now we can use that using the average velocity formula, which just says how far you go equals average velocity times time. So if your average velocity was 10, the amount of time that the thing spent going up, because that's the only part we're interested in right now, is 2 seconds. We're going to use this peak time, not the total time, because we're just looking at the portion of its flight when it was going up. When it was going up, it had an average velocity of 10, and it spent 2 seconds doing it. And if that's the case, then the maximum height of the football was 20 meters above the ground. This one's fun. Wanting to know how deep a well is, you throw your little brother down it. If he hits the bottom exactly 3 seconds later, how deep is it? If you're feeling a little more friendly, maybe you could just drop a stone, but dropping a little brother is pretty fun as well. Now that you've seen a couple problems solved like this, I'm going to start going a little bit faster to show you just how powerful these techniques are if you really master them. Right off the bat here, we know that the starting velocity was 0 because you just dropped him down. Final velocity was 30 because he fell for 3 seconds and got 10 faster for every second that he fell. And we know that time is, that would be a 3 seconds that he fell. Next, we're going to use the average velocity trick. Now, if he started at a velocity of 0 and his final velocity was 30, then his average velocity going down was 15 meters per second. It's the middle between 0 and 30. By the way, you might notice that I'm missing the negatives on this problem. That's because everything in this problem is happening in the down direction, so I'm simply calling down the positive direction. But if you wanted to, you could include negatives on these numbers, and you would still get an answer that makes sense. If you work out the problem, if you fell an average of 15 meters every second, and you spent 3 seconds doing it, then the well was 45 meters deep. You can actually calculate very easily, without doing a whole lot of complicated calculations, how high a building is. All you need is a rock and a stopwatch. Or a little brother if you want to try it that way.